Alright, this particular section will be section 4.4. And with section 4.4, we have double and half angle identities. Double and half angle identities. Okay, so again, this is going to be one of those sections where I want you to read the proofs in the book to see how we get these identities, but I'm just going to work out the problems pertaining to them. Okay, so go back, make sure you read the proofs, understand where that particular identity is coming from. It's going to help you make sense of it better. So we're going to start out this particular section with a verification. Sine of 2x equals 2 tangent x all over 1 plus tangent squared x. Okay? Well, I don't see anything good here that we can use, so that's going to help us get the sine. I'm using the right hand side is what I'm going to try to use to simplify to get sine 2x, but in order to get tangent into a sine, I'm going to have to change everything back to sines and cosines. So let's change all of our tangents to sines and cosines. Alright, well, we've changed it to sine and cosines. Now I see a complex fraction. So what I'm going to do is I'm going to multiply the numerator and the denominator by cosine squared x. That will clear my fractions so I don't have a complex fraction anymore. Okay, so at this point I have 2 cosine x sine x on top after I multiply through. When I multiply through on the bottom, I'm going to have cosine squared x plus sine squared x. Well, this is great because I know the bottom part's 1. That's not a big deal. And the top part is an identity as well. The top part is our double angle identity, sine 2x. Sine 2x. So we have simplified this down and verified our identity, sine 2x. Sorry to have to write that below there. Ran out of room, but sine 2x. Okay, so verifying that identity. Make sure you can verify all of these identities. Now, one other thing we want to make sure you can do is finding exact values. So for instance, let's find the exact values of the cosine of 2x and the tangent of 2x if sine x is equal to 4/5 and x is between pi over 2 and pi. Now don't let this right here confuse you. What is that telling you? X is in quadrant 2. Okay? X is in quadrant 2. That's just a different way of writing it, so don't let that confuse you. So what I'm going to do is I'm going to draw my reference angle. My reference angle looks like this. And I have sine is opposite over hypotenuse, so that's 4 over 5. So we need to find A. Now, why do I need to do that? Because first things first, I'm going to find cosine and I'm going to find tangent. Because if I can do that, that can lead me to cosine of 2x and sine and tangent of 2x. All right, so using the Pythagorean theorem, you would get 3 here. Now, since this is in quadrant 2, but we know this has to be a negative 3, right? Because it's in the negative direction. So, cosine is adjacent over, cosine is adjacent over hypotenuse. So we have negative 3/5. And tangent is opposite over adjacent, so that's 4, negative 4/3 would be tangent. Now, we were given sine. So, we're looking for cosine of 2x. Well, you can't just plug anything in for x, okay? So don't think that. But we have an identity. Cosine 2x is 1 minus 2 sine squared x. Alright, so we do know what sine is. That was given to us. Sine is 4/5. So that's 4/5 squared. Okay? Do the calculator work on that. And you're going to get negative 7/25 for the cosine of 2x. So see, we really didn't have to find cosine. I got a little ambitious on that one. You did need the negative 3 though to be able to get your tangent. But now we found cosine 2x. Now we can use this tangent here and we can find tangent 2x because the tangent of 2x equals 2 tangent x over 1 minus tangent squared x. So we know what tangent x is now. It's negative 4/3. We solved for that earlier. And so we can substitute negative 4/3 in both of these. So this is going to be a negative 4/3 squared down on the bottom. Do your arithmetic here, and you should get 24 over 7. Okay, 24 over 7. So hopefully that makes sense to you using these double angle identities. Now, let's move on to the half angle identities. Again, look at those proofs in the book, okay, in this section, section 4.4, so that you can understand the identities a little better. But I'm going to show you how to use these half angle identities. And so, for a half angle identity problem, find the cosine of 165 degrees using a half angle identity. Okay? Using a half angle identity. Well, the half angle cosine rule is this. The cosine of a half angle equals plus or minus the square root of 1 plus cosine x over 2. Now that's the rule. So I know my whole angle is 165. So 165 has to equal x over 2. So we need to figure out what x is. Well, x is 330, right? So what I can do is I can substitute 330 in my formula here. Okay. Now, since notice this plus negative here. Where is 165 degrees? 165 degrees is in here. So cosine in that particular quadrant is going to be negative. So since cosine is going to be negative in that particular quadrant, there's no need in you even worrying about the positive version of that square root. We're just going to worry about the negative side since it's in quadrant 2. Now, 330 is also a 30, 60, 90 triangle. It's also one of our angles for on the unit circle. So go ahead, punch this out, and the cosine of 330 is the square root of 3 over 2, all over 2. Now, I'm going to get rid of this complex fraction look, multiply the numerator and denominator by 2, and that gives me 2 plus the square root of 3 over 4. When I multiply this by 2 and this by 2, doesn't change my fraction, just makes it a little easier to work with. So, I can simplify this into the square root of 2 plus the square root of 3 all over 2, because the square root of 4 is 2. So see, I can, and this is a negative, remember. Make sure you don't forget your negative like I did right there. This is a negative because cosine of 165 is in the second quadrant. So here's your answer, and you could easily punch that out in the calculator and double check it, okay? Just like we talked about in our last section. Alright, so let's look at one problem kind of like we had with double angle identities. You're going to have the same kind of problem with the half angle. And that's find the exact value of sine of x over 2, cosine of x over 2, and tangent of x over 2. If sine x is negative 3/5 and x is between pi and 3 pi over 2. Now again, what is this saying? This is saying quadrant 3. Okay, quadrant 3 is all that means. X is in quadrant 3. Alright, so we have to do this the same way we did before. Let's draw our reference triangle first. Alright, so we know that this is negative 3. This is 5.